quick introduction. My name is Mostafa Toloui. I lead the product management for Holoscan that you're going to hear a lot about. Holoscan is a platform that has multiple components. The main focus today is going to be on Holoscan SDK, which provides you with AI sensor processing, and it's an open source software. But what is this Holoscan software? Let me just start with 3 use cases that have used Holoscan software, and you're going to hear throughout the day from some of them. But as you see, these are applications, as we call them in our team, from surgery all the way to satellite. They are not all medical applications. You see on the far right side, radio astronomy. In the middle, you see laparoscopic surgery. But one might ask, what does endoscopy application, laparoscopy application, all the way to radio astronomy have in common? And I'm going to just quickly walk through those to build the case why we built Holoscan and what are the advantages of using Holoscan in your applications. Let's just start with the first one. The first application that we are talking about is the application that Cosmo IMD built for Medtronic. And this application, you have multiple functionalities, multiple different end goals in mind with respect to endoscopy that comes through third-party applications deployed on this hardware that is called GI Genius. So the use case requires high capability when it comes to latency. It requires all-in-one platform to build your end-to-end AI sensor processing. It obviously, as we talk about multiple different AI applications running in parallel, requires multiple model inference. And also from a production readiness, we are talking about medical devices, and many of you are familiar with this field, has very high bar for what it could be called as a software as a medical device. So also they wanted to build an open platform. So building an open platform means different developers are going to use machine learning framework to build their applications. So you need to have that cross compatibility, whether somebody builds in PyTorch, somebody is using a Monai model, somebody is going to bring a Tau model, depending on where they start building their applications. The second application that you're going to hear in more detail is about surgical robotics. In this case, a hardware has been used as a sidecar to a surgical robot, and Holoscan software has been used for that AI sidecar to run AI-assisted virtual reality for this surgical robotics that assist with surgeon with observation of the organs and critical segments of the anatomy through the lens of augmented reality. So as you see in the pipeline also, you see a video, laparoscopic video coming in. You go through a pre-processing. You do some AI inferencing. You do post-processing. You do visualization, and you bring it to vision tower of the surgical robot for the surgeon to see it, consume it, and act based on what they are seeing. So you already might have seen some commonality between the 2 use cases, but clearly you are in the operating room. You have very critical requirements when it comes to the real-time aspect. You want to run multiple AI algorithms. You have the requirement to be able to bring the entire AI pipeline under the same umbrella when it comes to your development. And obviously, when it comes to this specific application, you want to build it in a way that is compatible with different surgical robots or different medical devices. So that integration and interoperability and IO integration needs to be easy, almost to the level of plug and play. And clearly the same thing here, right? As you're working with research organizations, you want to have that adaptability across different model architectures. The last application is about radio astronomy, trying to find signature of life in outer space. So in this case, completely a different application, completely different requirements. But when you think about the main pipeline, you still see a sensor on one side, you bring in the data, you do pre-processing, you go through the further accelerated compute for channelize and beamforming, you do multiple AI inference. One of those AI models is going to help you to have a smart sensor, whether you are capturing the right signal or not. The other one is going to help you to have a smart storage, meaning that you go through the data rather than having gigabytes and gigabytes and terabytes of data that doesn't have any insight in it to be stored. This AI model allows you to have a smart storage as well. And then ultimately you do the visualization. As you see the pipeline, you see again, a lot of commonality across the board, the real-time and low latency requirement, all in one development platform, having multiple AI inferences and AI models running in parallel, high bandwidth, in addition to the low latency is a requirement here, and obviously scalability from edge to data center. So you saw all those commonality across the three use cases from surgery to satellite. But the core of what we have seen across all of those is something like what I'm showing in this page, a generic pipeline for sensor AI processing. On one end, you have your sensor, you have your I/O solution, you bring in your data, you want to move the data at the speed and have, in the case of using GPU, direct to GPU, so you have zero copy, the pre-processing, AI inference, post-processing, and then once you create your insights, now whether you're going to visualize, you're going to actuate your robot based on that signal, or you're going to do certain analytics. Different use cases have different kind of a end goal in mind with respect to this pipeline, but the core is the same. When we started building Holoscan, we realized you can't build this pipeline with multiple different tools at different stages of this pipeline. But what was absent was an all-in-one solution that you can build the end-to-end sensor AI processing under the same umbrella. While the umbrella and the platform is performant, it is not complex to use, meaning that we are abstracting away the complexities. So later on, you're going to dive much deeper, but Holoscan provides you with two APIs, both Python and C++, whichever you are more convenient with, you can use to build your AI sensor processing application, and also gives you a head start on the performance. Rather than going through optimizing the performance, you start at a very high level already based on the way that we built our platform and the operator-based programming. So to sum it up, on one end, you have sensors. On the other end, you're going to have models and algorithms. We are bringing the capability of bring your own sensor that later on you're going to hear from my colleague Leela about our sensor bridge capability, Holoscan Sensor Bridge, that allows you to have a plug and play solution for bringing different sensor modality. When it comes to models, you're going to have different architecture, different machine learning frameworks. We have multi-backend support, allows you to bring your own model, then build your AI inference application in a very low-code, high-performance environment. And this software package is open source Apache 2 license, and then you can build a production-ready software and application. So 3 goals in mind when we built Holoscan was production readiness, performance, and usability. So we built it by abstracting away the complexity, giving you easy to consume APIs, both Python and C++. We built it very highly performant. It is built on top of TensorRT, Triton, DPDK, Vulkan, you name it, different kind of libraries for accelerated computing and IO. And also, it gives you that performance in the lens of production readiness, because we know our end developers are building for medical device use cases. So with that in mind, I want to highlight one of these frameworks that you might use for your model, which is Monai, and that's why you are here. This is part of Monai Days. So we built Holoscan, and in a very compatible way to Monai. When you have a Monai model, it becomes almost a drag and drop and build your application. We have this repository called Holoscan Reference Applications that my friends are going to, at the end of this call, share the link with you. Take a look at it. There are multiple examples of bringing a Monai model and running your inference in Holoscan. As I said, Holoscan software is open source. Hopefully by the end of today, you download it, give it a try, and build your application and see how much of what I claimed here is accurate. Hopefully it's going to be to the positive side, and you're going to see even much better performance and usability that I claimed here. As I said, Holoscan reference applications, it is going to be a repo of already built templates of applications from medical all the way to non-medical applications that you can go and use as a template to get a jump start to your application building. It is already easy to build your own application, build your own event operators, but we give you some of those pre-built access as well to just make it even easier. You see Monai name a couple of times here. As you are working on your Monai model and you have familiarity with this community, go through those examples. It makes it very easy how to bring in, do your model conversion, and run in Holoscan. As I said, Holoscan has that multi-backend support that makes that bring your own model capability a reality. So with all of that, one more time, I'm going to go through the hardwares that can support Holoscan. On the top, you see sensors, models, and applications that you use Holoscan software. It is hardware agnostic, whether you're using our embedded models in Jetson, whether you're building it on your laptop on an x86 machine, or you're using our IGX, which is highly performant enterprise edge, all the way to data center and cloud. Same software stack can be applied across the board. You build it once, you can deploy it across the board, because in edge solutions, we are aware of the fact that one size does not fit all. So you have different form factor, power, and budget requirements. That is why we built Holoscan in this way. It's an open source software that is hardware agnostic. And you see from credit card size hardware here all the way to data center and cloud that you can run your software and application and build your software and application and run them efficiently on. Across the day, you're going to hear a lot about robotics. You're going to hear a lot about AI enablement and software defined from different developers that have built on Holoscan. The reason and the common thread across the board during the day is our vision for future of medical devices that is going to be software defined, AI enabled, and robotics. With that, I'm going to just wrap it up quickly, pass it back to you, Michael. I know we have a packed agenda, so we can get started with the first presenter.